Completing the square is a process where you're doing exactly that. You're completing the square, and it's a way to solve a quadratic, or it's a way to find the vertex of a quadratic. So let's take that idea, and we did an experiment in class, but let's take that idea and say, what would happen if we had 10 x's? So we have 1x squared, and then we have 10 x's. Well, I'm going to put 5 of them over here and 5 of them over here. And then I'm going to complete the square by putting little ones all in here. Okay. And if I do that and I complete the square, that's a 5 by 5 square. Well, 5 times 5 is 25. So how do we get there again? Well, we take our b, and our b is whatever's in front of x. That's our linear term. And we line them all up, and then we complete the square. In other words, we're trying to figure out what is the perfect square. And so we end up with 25 little boxes. So what that means is I end up with a square. So now let's think about this. What multiplies to 25 but adds to 10? That's x plus 5, x plus 5, which is what we wanted. We wanted a square. Now if you look right over here, isn't that what we did? Isn't there 5 of them? Isn't there 5 little x's? Okay, so now I have a perfect square. That's x squared, that's 5x, that's 5x, and that's 25. That's x squared plus 10x plus 25. So completing the square is a way to make a perfect square. So how do we use it? What's its purpose? Well, let's go forward. So we have x squared minus 12x minus 64. And minus 64, we just don't like it. It's not a perfect square. It's annoying us. And so if it's annoying us, let's shove it to the other side. So if it's a negative 64 over here, what is it when we put it over there? It's a positive 64. And what we're going to do is we are going to make the perfect number. We didn't like negative 64. It wasn't perfect for us, so we shoved it out of the way, and now we're going to make the perfect number. And we decided that inside of our little puffy cloud there is going to be the perfect number, and that is going to be b over 2, and then we're going to square it because we said b was the middle number, and we're going to divide it into 2, and when we're making our little square, and then when we finish making our square, that's squared, isn't it? Well, b in this problem is negative 12, so negative 12 divided by 2 is negative 6, and negative 6 squared is 36. Now your middle school teacher told you that whenever you just decided to add something to one side, you have to add it to the other. You have to keep it balanced. You can't just add whatever number you want. You have to add to both sides. So now I need two things that multiply to 36 but add to negative 12. Multiply to 36. Well, 6 and 6 jumped in our head. Should they be positive or negative? They need to be negative. All right. Negative 6 times negative 6 is positive 36. Negative 6 plus negative 6 is negative 12. And is there a way we can kind of shorten that? Oh, yeah. What was negative 12 divided by 2? What was negative 12 divided by 2? Negative 6. That's what goes right there. That's how we know it. All right, so is this the right way to write this? No, it's not. If I have 4 times 4, I don't leave it 4 times 4. I say it's 4 squared. So this is x minus 6 squared. And what equals on the other side? Well, if I add those two together, I get 100. Okay? Now, there are two things I can do with this, and I'm going to start with just solving. So let's solve this. If I take the square root of both sides, that does not hurt the equation. If I take the square root of both sides, it does not hurt the equation. So, and taking the square root of a square, what does it do? In essence, it just gets rid of it, doesn't it? So this is x minus 6. And what is the square root of 100? Well, when we were in Algebra 1, and we said, and your teacher said, what is the square root of 100? You all shouted 10. But in Algebra 2, we realized that it's not just 10, it's also negative 10. Because negative 10 times negative 10 is still positive 100. And the way we're going to write that is we're going to let everybody know that it's a positive and a negative 10. Well, our next step is to move this 6 to the other side. So if I scratch it out over here and it's negative, it's going to be positive. And now I realize I've got two answers. I've got 6 plus 10, and I've got 6 minus 10, and that's 16, and that's negative 4. And doesn't that make sense? Because quadratics have two answers. Quadratics usually have two answers. They usually cross the line how many times? Two answers. All right, so let's think about this from the beginning. All right, what happens if I have 8 is my b? Of course, we don't like 2, so we shove it to the other side. If it's a positive 2, it becomes a negative 2. All right, what is 8 divided by 2 squared? Well, 8 divided by 2 is 4, and 4 squared is 16. And our middle school teacher told us we had to do it on both sides. Now, I need something that multiplies to 16, but adds to 8. Okay, multiplies to 6. I think that's 4 and 4. And should we have had a hint on that? What again was 8 divided by 2? Oh yeah, that was 4. We already knew what that was. That was our hint earlier, was that's what it was for. Over here we have 14. Now this is not the correct way to write it. If I have 4 times 4, I'm supposed to write 4 squared. If I have x plus 4 times x plus 4, I'm supposed to write x plus 4 squared. All right? And this is where we are. Now I want to stop right there because now you have to decide what you're going to do. You can either find the vertex or you can solve it. So it kind of depends on what you want to do. We're going to do both things, but let's see what we're going to do. What if it says find the vertex? Well, that's actually very easy. All I do is subtract 14 from both sides. I move it back. So I have x plus 4 squared minus 14 equals 0. And let's go back to first week in September. What does that make it do? Left. What does that make it do? Down. So the vertex is negative 4, negative 14. We have been learning that since September. Negative 4 and negative 14. Left and down. That is the vertex. All right. Now, same problem, only this time we want to solve it. So our next step is to take the square root of both sides. If you take the square root of a square, it all cancels out. Square root of a square cancels out, and all I have is x plus 4. And then when I take the square root of 14, I get some ugly number, so I'm going to leave it. Remember, it has to be positive and negative because we're in Algebra 2. Square root of 14. And to get x by itself, I need to move that 4 to the other side, don't I? So, and I'm going to put it like this for a reason, because the book is always going to, I don't mind if you put the negative 4 at the end, but the book is always going to put the negative 4 at the beginning, so I'm going to do that here. Negative 4 plus or minus square root of 14. Now that is a decimal, therefore we stop. We don't deal in decimals and radicals, so we're going to stop right there, and this is going to be our answer. Okay. Now it does get harder because there's something special that we've been doing up until now. All right. We did not like negative 36, so we shoved it to the other side, which makes it positive 36. All right. And we know that puffy clouds are b over 2 squared. That's what a puffy cloud is. So what is 9 over 2? Well, it's 9 over 2. Your instinct will be to change it into a decimal. Don't. And then 9 over 2 squared. Well, that's really easy. That's 81 over 4. 81 over, oh, you mean it's just 9 is squared is 81, and 2 squared is 4. Oh, I get it. Okay, so that's 81. All right, now, this is where it gets a little challenging. What was 9 divided by 2? 9 over 2. So that's what goes right here. X plus 9 over 2. Now I can go and get my handy dandy calculator, and I can try this out, and I will realize that if I add 36 plus 81 over 4, I get 225 over 4, and I do not want to do decimals. I want to leave it just like that, and there's a reason for it. Now this is not the correct way to write it. What is the correct way? And the correct way is to write x plus 9 over 2 squared and 225 over 4. All right. And then we have to decide, what do we want to do? Do we want to find the vertex, or do we want to solve? And of course today we're going to do both of them. All right, so this is what we have. If it says find the vertex, that's easy. I'm just going to move this back over. So that's x plus 9 over 2 minus 225 over 4. And we're going to go back to September. That's left. That's down. So our vertex is negative 9 over 2, negative 225 over 4. See, we took, when it's going down, we already knew that's a negative, but when it was going left, we had to show you that it was going left by making it negative. All right, what happens if we want to solve it? Well, our first step is to take the square root of both sides. Then that is, what is square root of a square? It gets rid of everything. So I have x plus 9 over 2. Now this is kind of interesting. You haven't learned much about it yet, but you can do this. Square root of 25 over the square root of 4. Well, it just so happens that the square root of 225 is 15, and the square root of 4 is 2, and we know it's algebra 2, so it's that plus minus thing. And then, of course, what's your last step? I just need to get 9 over 2 over there. So x equals negative 9 over 2 plus or minus 15 over 2. And remember, I'm supposed to have two answers, so I'm going to look for two answers. What is negative 9 over 2 plus 15 over 2? And what is negative 9 over 2 minus 15 over 2? And what I end up with is, let's see, this ends up to be negative 12, and this ends up to be 3. So those are my answers. Completing the square is not hard, but it's a very lengthy, very detailed process. And what is it that we have the most trouble with? Negatives. Every time, everywhere, it's the negatives. So, I thought of this one. We're so scared of negatives. I thought we would talk about the fake Martian invasion, Orson Welles, and it scared everybody to death, even though it was just fake. And you ought to read about it sometime. It's a very interesting. It's War of the Worlds. Read a newspaper article about it sometime. It's really interesting.